In this first slide here, we're going to look at the graph for y equals 2x. See how it's got a red bit next to it? Okay, and if we look across at the graph, we've got a red line. Okay, so we've got y equals 2x. You'll see there's some other lines there as well, some other equations there that we're going to look at. But this first one, y equals 2x. So we're going to be looking for a connection between these different equations here. Okay, so I wonder why this graph has got equation y equals 2x. In particular, why is there a 2 there? Now, remember when we were finding the gradient and I said to you, think about where the line crosses over like these wee dots, okay? So, it's thinking about where the red line crosses over points like this. So there's one here and there's another one here. And what I'm going to do is I'm going to find the gradient. So draw a wee triangle, use my National 4 formula, height over horizontal. What's the height of my triangle here? The height of my triangle is 2 and its horizontal distance there is 1. One last thing I'm going to check. Remember, if I start from the left-hand side, is it going up or down? Right, so from the left, go towards the right-hand side, it's going up the way. So it's a positive gradient. So all I need to think about is doing 2 divided by 1, which makes 2. And that is there, y equals 2x. So maybe this equation is 2x because the gradient is 2. Let's have a look at another one. Okay, so this time we're looking at the graph for y equals 3x. Okay, and this time see how it's got the wee blue ball there? And we've got a blue line. Okay, right, so same idea again. This line is called y equals 3x. So remember, when we're trying to find the gradient, we're thinking about these wee places where the lines cross over. There's one there that's on my line. If I keep going up, there's another one there. Okay, there's many places on the line, many points on the line that we could pick. So, if I want to find my gradient, I'm going to draw a triangle in like that. That's the easiest way to do it. And I'll write down my National 4 formula, which I like to shorten down to height divided by horizontal. So if I look at my triangle that I've drawn here, how tall is it? 1, 2, 3 boxes tall. It's a height of 3, and how wide is it? 1. Again, just make sure that if we start from the left-hand side and move towards the right, it's going up the way, so it is a positive gradient. 3 divided by 1 makes 3. Now again, look. That 3 is a part of my formula, y equals 3x. On this next slide here, I have got both the graphs for y equals 2x and y equals 3x shown. So y equals 2x has got the red line, y equals 3x has got our blue line. Okay, so the red one is y equals 2x and the blue one is y equals 3x. So what I can see here is that we've got the red line, but the blue line is steeper. Now that's what we would expect because the red line's got a gradient of 2 and the blue line's got a gradient of 3. So it is going to be steeper. On the next graph, we have got our y equals 2x. We have our y equals 3x, and the green one is our y equals 4x. Now if we start from the y equals 2x, we know that the gradient for this line is 2, we know that the gradient for the blue line is 3, so it makes sense that we've got the red line and then that the blue one is steeper because the gradient is more, and then the green line is even steeper again because this one has got a gradient of 4. So as the gradient increases, you can see the lines getting steeper. So this next slide that we've got, I've gone a slightly different way. This time, I've got y equals 2x But underneath that, this time I'm doing y equals a half x. Now, if the gradient for this one is 2, the gradient of this one is going to be a half, or 0.5. That number's bigger than that one. That one's got a bigger gradient than that one. This one has more steepness than this one. So let's look at the red and the blue line over here. We have got y equals 2x, whoops, wrong pen, y equals 2x. And the blue one underneath is y equals a half x. So again, the gradient is 2, so that's steeper than this one that has a gradient of a half. Okay, one more line has been added this time, so we have got y, wrong pen again, y equals 2x, y equals a half x, and looking over here, I've added a purple line this time, and the purple line has got a gradient of, I don't have a purple pen, y equals 0.2x, so that's got a gradient of 0.2. So again, you can see what's happening with the gradient here. We've got a gradient of 2 from this equation, so that's steeper than this line, which has a gradient of 0.5, which is steeper than this line, which only has a gradient of 0.2. One more to look at. You might just be able to see it, but for this line here, there's a green line coming along here. And that green line there is for y equals 0x. Now, that's not the shortest way to write that, but let's have a think about what we found so far. We found that the number in front of the x gives us our gradient. So we don't have a gradient for 0, it's flat, right? Now, there's a shorter way to write y equals 0x. If you don't have any x's, you don't have anything. So the shortest way to write y equals 0x is just to write y equals 0. And it's actually flat along the x-axis. So to summarise what we've learnt so far, if we've got an equation y equals 2x, then the gradient of this line is 2. And if we've got an equation y equals 3x, then the gradient of this line is 3. Okay, 3 more graphs to look at just before we move on. So the red graph is y equals minus 1x. Now remember, we don't need to write a 1 in, so that red line is minus x. The blue line is y equals minus 2x, and the green one is y equals minus 3x. So as we go from minus 1 to minus 2 to minus 3, it's getting steeper. So a gradient of minus 3 is steeper than a gradient of minus 2, which is steeper than a gradient of minus 1. Okay, here's some questions for you to do, so pause the video and the answers will come out in a few seconds. So pause. Okay, here's your answers for exercise 1. It's quite common for us to see people writing the gradient as 3x. Please, the gradient is just 3. Okay, so none of these answers have got an x on. Okay, and then here's your answers for the ones that are the steeper lines. If there's any of those you got wrong, please tell me and I can show you why each of those answers is the correct one used in the Desmos graphing program. Okay, so on this slide I have a different variety of graphs that I'm going to look at. So the first one with the red wee ball at the side, y equals 2x, y equals 2x add 1, y equals 2x plus 2, and you can see they all start with y equals 2x. Now we know that when we have 2x, that means that the gradient is 2. So all of these lines here are going to have a gradient of 2, but they can't all be the same line. So let's have a look at what happens as we add an extra one in. Okay, so what's happened here is we have our red line, which is our y equals 2x, and we have our blue line, which is y equals 2x plus 1. So 1 has been added on. The line has moved up one place. Pick a point, everything has moved up one place. In a minute. So this next one here, my green line is y equals 2x add 2. So if I go back to y equals 2x, which is my red one, 1, 2, and I get a point on the green line. If I start from the red line, 1, 2, and I'm up to a point on the green line again. So the green line is just the red one moved up 2. Now, something I want you to see here as well, y equals 2x. The blue line is y equals 2x plus 1. Now what I want you to think about is 2x actually being 2x plus 0, just so that it looks similar, so its equation looks similar to these ones. Okay, so actually if we have a look at our graph, it comes down, our red one, it comes up and it crosses over the y-axis at 0. If we look at our blue line, it comes up, crosses over the x-axis, but I'm more interested, where does it cross over the y-axis? Okay, now if we have a look, 0 and then 1. So the line y equals 2x plus 1 crosses over the y-axis at 1. And then if we have a look at our green line, so let's come up our green line, it comes over the x-axis there, and then it comes up and it crosses over our y-axis there. Now where does it cross over our y-axis? Let's have a look. There's 0, it crosses at 1, 2, and that's where that plus 2 comes from. So we now know that this number here is our steepness for our line, so they've all got a steepness of 2, and the plus 0 in this case means that it goes through the y-axis at 0. The next one, when it's got a plus 1 in the end, it crosses the y-axis at 1. And this one here crosses over the y-axis at 2. So we're just going to have a wee look at a few more of these to make sure that's right. So this time here, I have added on the graph for y equals 2x take away 1. So you can see it's got the same steepness as the other 3 graphs that we already knew about. But let's have a look. If I come up this line, where is it going to cross over? There it goes. There's where it crosses over the y-axis. Where does it cross over the y-axis? Oops, where's my pointer gone? 0. Down 1, it crosses over the y-axis at -1. One more to look at. So I've just added in the graph for y equals 2x take away 2. So I'm already thinking, because I've done this a few times before, if this has got -2 here, then if I look down my y-axis, 0, -1, -2, yes, it crosses over the y-axis at -2. So when we look at the equation of a line, the number that's in front of the x is our gradient, and this number here that's on its own, that number there is where it crosses over the y-axis. Now this gives us a general equation that's called y equals mx plus c. Now we already know that m stands for the gradient, but c is something new. C is where it crosses the crosses the y-axis. Now the proper name for c, we call it the y-intercept. Now when we write down our gradient, we write down m equals 2. Okay, so I'm thinking about this equation here and it being in this form here. But when it comes to writing down the y-intercept, what we do for the y-intercept is we actually give it as a coordinate. So if you think about the coordinate for this point here, which is on my line, 2x take away 2, to get from the centre down, we have to go down 1, 2. How much do we move along the x-axis? None. We're just moving down 2. Okay, So that's for the line y equals 2x take away 2. If I look back to y equals 2x plus 1, again, the gradient is 2. I get my gradient, remember, from the number that is in front of the x. 2x plus 1 was that blue line there, wasn't it? So to get the place where it crosses the y-axis, starting from that 0 point there, the origin, I move along nothing. I have to move along nothing and then, sorry, and then up 1. So what we have to be careful of is that we give our gradient m equals, but we give our y-intercept as a coordinate. Just be careful with that bit. Okay, here's exercise 3. This is the last thing that you're going to do today. So for this one here, write down the gradient and the y-intercept of each line, remembering to give the y-intercept as a coordinate. So if you pause the video now, because the answers will pop up, so make sure you pause now. And there's your answers. Again, remember that the gradient does not have an x on it. And remember your y-intercept, where it crosses over the y-axis, you go along nothing and up 3 for this one. So notice they all start with 0 because we're just going up or down the y-axis. So we're not going across the x-axis or anything, just up and down the y. Okay, well done.